And these stars were formed out of an interstellar medium that only consisted of hydrogen and helium. Now I like Ahna will Now I like Ahna to share with us the life cycle of stars.
Thank you, Bibek. Good morning. Hi, friends. I am Ahna. Today, I will tell you about the stars, nebulae, and the stellar evolution. It's a. I'm sorry. It's a dark, clear, and a moonless night. You look up into the sky. You see thousands of stars arranged in thousands of patterns and constellations. The light from these stars travel great distances to reach Earth. But what are stars? How far are they? Are planets around them? How do they form? Do stars ever die? So today we will look at the fascinating world and the nature of them. First we will learn about the nebula. The word nebula is derived from the word cloud. It is a cosmic cloud of dust and gas floating in space like in the pictures below. The plural of nebula is nebulae. Nebulae are the basic building blocks of the universe. They, they contain solar systems are made. A fine example of an emission. They are among the most beautiful objects in the world that glow with rich colors and swirls of rich light. Stars inside this cloud of dust make them glow with the color of red, blue, green, etc. Most, most nebulae are composed of 73% hydrogen, 10% helium, 0.1% carbon, 0.1% nitrogen, calcium, iron, potassium, and magnesium. Types of nebulae. Emission nebula. The first type is the emission nebula. It is a cloud of high temperature gas. Within this type, a star energizes the atoms in the clouds with ultraviolet radiation. They take out their own radiation. A fine example of an emission nebula is the Orion Nebula. Reflection nebula. The second type of nebula is the reflection nebula. It differs from an emission nebula. It doesn't take out its own radiation. It is a cloud of dust that reflects its radiation from stars that are near. They are usually blue in color. They are frequently the sites of star formation. The Trifid Nebula in Sagittarius is a good example of a reflection nebula. A dark nebula is a cloud of dust and gas that blocks the light from objects that are behind it. They are very similar to reflection nebula and look different because of the placement of the light source. They are usually seen with the emission and reflection nebula. Planetary nebula. A planetary nebula is a shell of gas produced by stars as it nears the end of its cycle. They actually have nothing to do with planets. They are named this way because of their round shape. The Ring Nebula in Lyra is one of the best examples of it. It is created by a supernova. Supernova remnant. Supernova remnants are created when a star ends its life in a massive explosion known as a supernova. The explosion blows a large amount of the star's matter into space. This cloud of matter glows with the remains of the star that created it. One of its examples is the Crab Nebula in Taurus. Stellar evolution. Now we know all about the nebulae and all their five interesting types. Now we're going to learn about the stellar evolution, the evolution of stars. I will also tell you about the birth of the star and the death of the star. So let's get lost in outer space and learn about them. The formation of stars. Clouds of gas and dust are disturbed by the gravity of a nearby phenomena. The disturbance causes clumps to form and draw gas inwards. The collapsing clump begins to rotate and flatten into a disk of gas and dust. The disk rotates faster and faster, pulling more material inwards, creating a hot, dense core called a protostar. When the protostar becomes hot enough, hydrogen atoms begin to fuse, producing helium and energy. After millions of years, a bipolar flow erupts from the protostar and blasts away remaining gas and dust. Death of a star. Several billion years after its life starts, a star will die. How the star dies, however, depends on what type of star it is. Stars like the sun. When the core runs out of hydrogen fuel, it will contract under the weight of gravity. As the core contracts, it heats up, causing them to expand. As the outer layers expand, the radius of the star will increase and it will become a red giant. When the helium fuel runs out, the core will expand and cool. The upper layers will expand and take out material that will collect around the dying star to form a planetary nebula. Finally, the core will cool into a white dwarf. This process will take a few billion years. Stars more massive than the sun. When the core runs out of hydrogen, these stars fuse helium into carbon just like the sun. However, after the helium is gone, their mass is enough to fuse carbon into heavier elements. After that, the core can burn no longer. The star collapses by its own gravity, and the core, which is about the size of the Earth, shrinks to a neutron core with a radius of about 10 kilometers. The outer layers of the star will fall inwards on the neutron core, thereby crushing it further. The core heats up to billions of degrees and explodes, supernova, thereby releasing large amounts of energy and material into space. The shock wave from the supernova can initiate star formation in other interstellar clouds. The remains of the core can form a neutron star or a black hole, depending upon the mass of the original star. Let us now learn more about our own star, the Sun, and the solar system we live in from Panache.
Panache, I'm unmuting you.
रुको।
Thanks, Ahana. Let me introduce you all to the solar system. The solar system came into being about 4.5 billion years ago when a cloud of the gas and dust collapsed, resulting in a solar nebula, a swirling disk of material that collided to form the solar system. It is located in the Milky Way's Orion arm. Our solar system consists of the Sun and 8 planets that revolve around it. Did you know? All planets except Earth are named after Greek or Roman gods. Sun. The Sun is like a ball of hot burning gases. It is made up of 75% hydrogen gas and 25% of helium gas. At its center, hydrogen atoms collide together at great temperature and pressure, and they fuse together to form atoms of helium. All of its heat and energy is produced due to this fusion. Most of the energy is radiated outward and takes 8.5 minutes to reach Earth. Fun fact, nothing can ever go near the sun. Anything that goes near it will melt because of its extreme heat. The planets. The 8 planets orbiting the sun can be divided into 2 categories, terrestrial and Jovian. The first 4 planets, Mercury, Venus, Earth, and Mars, are called terrestrial planets. They are made up of rocky material and have solid surfaces. They are smaller in size and do not have rings. They have very few moons. The next 4 planets, Jupiter, Saturn, Uranus, and Neptune, are called Jovian planets. They have multiple moons and rings. They are huge in size and do not have solid surfaces. Let's now look at all these planets together. Mercury. It is the smallest and fastest planet of the solar system. It takes 88 Earth days to complete one circle around the Sun. Mercury has no air, water, or moons. It is extremely hot during the day and extremely cold during the night. Venus. Venus is the hottest and brightest of all planets. It has high amount of carbon dioxide which traps heat inside it. As it can be seen in the morning and in the evening, it is called as the morning or the evening star. Like Mercury, it does not have any moons. Fun fact, while all the planets move anti-clockwise, Venus is the only one that moves clockwise. Earth. Here comes Earth, our favorite planet, also called the blue planet. Nearly 70% of the Earth's surface is covered with water, making it the only planet on which life is known to exist. It takes 365 days to revolve around the Sun. It has one moon, also known as its natural satellite. Mars is known as the red planet because of its presence of red soil, rocks, and rust like dust on its surface. It is also the only planet which might have supported life 3.7 billion years ago because of its watery surface back then. Fun fact, its size and gravity is half of the Earth, so you can jump 3 times higher on Mars than on the Earth. If you can jump 1 meter high on Earth, you will be able to jump 3 meter high on Mars. Jovian planets. The Jovian planets can be divided into gas giants made of helium and hydrogen and ice giants made of rock and ice. Jupiter. It is the largest planet in the solar system. Its size is so big that all other planets can fit in it. It also has rings around it, but they are very faint and therefore are hardly visible from Earth. Jupiter's great red spot is an enormous storm that has been raging for over 300 years. Fun fact, it is called as the vacuum cleaner of the solar system, as its gravity is twice than the Earth and it sucks all dust and comets from the space. Saturn is the most beautiful planet in the solar system due to its rings. Its rings are easily visible from Earth. It is also the lightest of all planets. It can float in water like a rubber ball due to its low density. It has 82 moons, the highest among all planets. Fun fact, if a storm starts here, it can continue for many months and years. Uranus, it also has rings made of dust. It is very cold as it gets very less sunlight. It takes 84 years to complete one circle around the sun. Fun fact, it is tilted and not straight. Due to this tilt, a season lasts for 20 years on Uranus as compared to 3 to 6 months on Earth. Neptune, the outermost planet. It is the coldest and farthest planet from the sun. It takes 165 years to revolve around the sun. It has 14 moons. Fun fact, it is the only planet which is not visible from naked eye from the Earth. Is Pluto a planet? Pluto was considered a planet before 2006, but not anymore, as it does not satisfy the third condition according to modified definition of the solar system. It is that it should have cleared its neighborhood. Other objects in the solar system orbiting the terrestrial planets is the asteroid belt, a flat disk of rocky objects full of remains from the solar system's formation. Another disk of space debris lies much further out and orbits the Jovian planets, the Kuiper belt, birthplace of many comets. Beyond the Kuiper belt is the Oort cloud, which is a collection of icy debris. It is considered the edge of the solar system. Our solar system is just one of the 500 solar systems in the entire Milky Way galaxy. To know more about galaxies, let's go to Ania.
Inaya, I have unmuted you.
Stop video.
Thank you, Panash. Hello, everyone. Today I'm going to tell you about the galaxies. What is a galaxy? A galaxy is a huge collection of gas, dust, and billions of stars and their planetary system. A galaxy is held together by gravity. Our galaxy, the Milky Way, also has a supermassive black hole at the center. Birth of the galaxies. There are two theories. First, galaxies were born when vast clouds of gas and dust collapsed under their own gravitational pull, allowing stars to be formed. The young universe contained many small lumps of matter which clumped together to form galaxies. This theory has gained more popularity in recent years. Zoo of galaxies. According to the best estimates of astronomers, there are at least 2 trillion galaxies in the observable universe. There are 6 categories of galaxies.
First, barred galaxy, second, irregular galaxy, then spiral galaxy, peculiar galaxy, elliptical galaxy, and lenticular galaxy. Why do we study galaxies? Observation of distant galaxies show us what the universe looked like at an earlier time in the history of the universe. By studying the properties of galaxies at different epochs, we can map the evolution of the universe. How are galaxies named and how many named galaxies are there? Mostly, galaxies are named after where they are located. About 1 million galaxies are counted. Milky Way galaxy statistics. Milky Way galaxy is a barred spiral galaxy. Its diameter is 100,000 to 180,000 light years. There are 100 to 400 billion stars in the Milky Way galaxy. Distance to galaxy center is 1 billion light years. It is 13.6 billion years old. Its mass is 13.6 billion solar mass. Number of stars in the Milky Way. Scientists had a major challenge in attempting to count the stars in the Milky Way galaxy. The only problem is that Earth and our solar system is located on one of the outer arms and we cannot get a really good view. We are 25,000 light years from the galaxy center, and the best estimate that they can come up with is around 100 billion stars. The stars are a part of a large disk that has a diameter of 100,000 light years. Interesting information. We have a supermassive black hole at the central core of the Milky Way galaxy that is named Sagittarius A star. That is believed the central core has the 4.3 million stars. Milky Way of the past is not the one we have today. Over the time, it has collided and merged with other galaxies. Milky Way galaxies, gas, stars, and dust orbit around the center of the galaxy at around 220 km per second. Some more interesting information that Milky Way is almost as old as the universe. Astronomers place the age of the universe at around 13.7 billion years and the Milky Way at 13.6 billion years. One star that you can see from anywhere in the world in the night sky is around 2500. New stars are being produced in the Milky Way galaxy at a rate of 0.68 to 1.45 solar masses per year. Milky Way has a halo. Astronomers think that there is a mysterious halo around a galaxy that is due to the dark matter. Over to Abir to know more about dark matter and dark energy, which will ultimately decide the fate of our universe. Over to you, Abir.
Okay, Abir, I am unmuting you.
Thank you, Anaya, and my greetings to everyone. Till now, you have learned how our universe was born, how stars, planets, galaxies, and many other things started to form. Now, I will take you to the fate of our universe. How do you think our universe is going to end? To understand how our universe will end, I would first explain dark energy. I'm sure you're familiar with the fact that gravitational force is an attractive force which acts between two or more objects and tries to bring objects closer. If this is the only force present in our universe, then we would have expected other astronomical objects to come closer to us, and our universe should have contracted over time. But we all know that our universe is not contracting but expanding. Edwin Hubble, a physicist in deep space, are moving away from each other. This leads to a picture of expanding universe, which I can easily explain through a simple experiment. I have a balloon here on which I have made dots using pen. Now let us blow some air in the balloon. As you can see, the dots are more separated from each other now. If I blow more air in the balloon, the dots will move even further from each other. You may consider the dots as galaxies in a balloon kind universe. Since our universe is not contracting but expanding, it indicates the presence of some repulsive forces in our universe. Very less is known about this repulsive force, and scientists call it the dark energy. Scientists think that dark energy is a kind of energy which acts opposite to gravity. It is a repulsive force which is present in our universe. It occupies the entire universe and accounts for most of the energy in it. It turns that roughly 68% of our universe is dark energy. What is the rest 32%? It is interesting to know normal matter like sun, stars, planet we observe adds up to less than 5% of our universe. This normal matter emits light and is thus visible to our eyes. To our eyes. The left 27% of our universe is made up of something called dark matter. What is dark matter? As I mentioned before, the normal matter we observe in space are objects that emit some type of electromagnetic radiation and are thus visible to us. Dark matter emits no electromagnetic radiation, so we cannot observe it directly. However, astronomers know that dark matter exists because its gravity affects the motion of objects around it. Dark matter and normal matter account for the attractive forces in our universe, which I call as the red team. Dark energy accounts for the repulsive forces, which I will refer to as the blue team. It is a fight between red and the blue team, which is going to decide how the universe is going to end. If blue team wins, the repulsive force will be more than the attractive force. And if red team wins, the attractive force will be more than repulsive force. You will be surprised to know that the blue team, which consists of dark energy, is not fixed. It is growing with the time. As the universe is expanding, the dark energy between space is decreasing. The question is, where does this energy come from? One can say that our universe is not just expanding, but expanding at an accelerating rate. In other words, the universe is expanding faster now than ever before, and in the future, it will expand even faster. This means dark energy is increasing in our universe at an ever increasing rate, which is causing the universe to expand at an accelerating rate. If the rate at which the dark energy is growing is not fast enough to overcome the attractive pull of dark matter, then the attractive pull will be more than the repulsive push, and the universe would someday start to contract and eventually get squeezed together in a big crunch, the opposite of the Big Bang. This would ultimately cause the universe to shrink and cause stars, planets, and entire galaxies to collide into each other. And the universe would, for all intents and purposes, collapse in onto itself. If the rate at which dark energy is increasing is there was a connection issue. If the rate at which dark energy is increasing is fast enough to overcome the attractive force from dark matter, then the universe will expand forever, although the expansion will slow down over time. Energy will be sapped away over time by the expansion of the universe, leaving everything just a fraction of a degree above absolute zero. In this big freeze, the universe will end up uniformly cold, dead, and empty. The third death, called the Big Rip, will be the most painful death of our universe. In this case, dark energy will be more than the dark matter, just like in the case of Big Freeze. But the amount of dark energy in our universe will be so large that the repulsive force will rip everything apart. This would tear apart galaxies, followed by black holes, stars, and even our own planets. Earth and humanity with it would be ripped apart as the universe full of single disconnected particles. With this, I would like to end the story of our universe. Although there are some questions which I often think about. Like, what was before the Big Bang explosion? And will our universe be reborn after its death? There are many such unanswered questions related to the mysterious universe we live in. With this, I come to an end and would like to thank you all for listening to us patiently. I, on behalf of my team members, Vivek, Ana, Panash, and Ania, would like to thank Science Club GNU and the Millennium School for giving us this opportunity to narrate the story of our universe from our eyes. Any questions or comments are welcomed.
Very nice, everyone. I'm really glad you pull up it so well. Abir, it would have been wonderful if your video was on. Can you please turn on your video for a second and show us? Your video was off the all time, but I didn't want to disturb you in between. So can you please turn on your video and say hi to everyone? You are unable to do that? Okay, never mind. So I'm really glad all the kids gave such a wonderful session, and if there are any questions, you may please raise hands. Yeah. Okay, are there any questions? Prateek had some questions. He was writing them on the chat window. I am unmuting Prateek, and maybe you can ask and motivate these kids.